So today we're going to take a look at the beginnings of how to make your RTS engine, have a little look at events, and we're going to be focusing on the user interface today, so how you can interact with the game. So if we start this up now, we'll have a quick look at what we're going to show. So yeah, we'll have a look at how we set the minimap up and how you can click it and move to different areas. Also show you how you get this white viewport area, and you can see there when you zoom in and out it changes. I'll show you how to do all that. Show you a bit of cursor management. As you see there, the cursors are changing, so obviously that's for move. See there, it tends to select if the unit's deployable, like that one is, it will do the deploy cursor. And you see there, there's the move cursor. So let's see how we've done it. So this is my events manager. it was quite big, the events manager, so I made it a partial class and spread it over several files. So see here, this is the main file. There's not really much very going on. You see we've declared some delegates. These are for all our different events. So you see there, we're going to take one that takes mouse event args, scroll wheel event args, screen edge event args, and keyboard event args. These are all custom event args that I've created, and I'll show you some of them in a bit. There you can see on here, you see in our late update method, we've got check mouse clicks, check keyboard presses, and check screen edge. And if you go to these other files, this is where the methods are. So our mouse clicks, see there, we're just checking if input get mouse button down. And if it evaluates as true as well, this is where we fire off the event. So you see there, new left button handler, that's our custom event arg. So the keyboards, again, they're pretty similar, so we're going through, we're checking if it's being pressed, if so we're raising the event and creating the event args. It's the same with the screen edge. It's also the same for scrolling, I think that's in mouse. Yeah, there you go, there's where the zooming happens. Some other things to take as well, when we're double clicking, I haven't implemented anything yet that uses a double click, but I will be doing. So you see here we've got the double click set up. There might be a more efficient way of doing that, but I thought that's quite a nice easy way of doing it, so I've set it up like that. So that's how the events work. Now the reason why it's done like this is so I can drop this events manager in any project at all. The events manager doesn't know anything about the RTS engine or anything like that, so any project to use I can drop this in and that's it, I'm ready to go to hook into my events. The only thing I would have to change some of my custom event args. Now I probably won't have to change the base class. So here, so my keyboard event actions, see I've got a base class here called keyboard event args, and you see my delegate takes that, yeah, keyboard event args. But I'm not actually using that. You see, in fact you can see that's an abstract class, so I can't use that at all. But then all these different keys derive from it. Now if you don't know what polymorphism is, this is a good example. Originally, if I show you, right, so this is my old user interface, this isn't the one I'm using anymore. But how I used to do this was, so I had a keyboard press handler here, and that's, where is it, keyboard press out, so that was hooked into the key action events. And then what happened was we had this big switch statement, and you say, alright, if it's this key then go to this method, or if it's this key you can go to this. It just massive switch statement, pretty ugly, not very nice, don't want that. And at this point as well, my keyboard event args was the main class, it wasn't just a base class, that was it. I didn't have any of these other files, these key 0 or key s. But I don't like that massive switch statement. If you get a switch statement or a big if statement, you can probably use polymorphism to make it a lot nicer. So what I ended up doing was making all these different classes. Now if I show you key s, so this, if you press S and there's any unit selected, you just want it to stop. So the command there, see there, I've got my command, and that does, it just gives the stop order. And you see there, if I go back to my old UI manager, see there's if we pressed S, we'd go to key S press method, and then it'd do that. But then, since I ended up creating all these other classes, so this is where the polymorphism comes in. If you look at my new UI manager, so now instead of that big ugly switch statement, that's it. That's all it is now, is whatever key comes in, I just tell it to do its command, and that's it. I can completely forget about it. No switch statement, no other methods or anything. All the methods are contained within their own class. So that's how polymorphism can work. And that's how the other things work. The button clicked handler, it kind of works the same. I use polymorphism to determine what method I want to call. Because with the button clicks, a lot of it depends on what's currently selected and what you're hovering over. So I need to get access to the current objects and the current object layer. So I kept all my methods in here. But I've just used polymorphism to call the correct method. So that's how our events work, and that's how you can that's how you pick up the button clicks and all that kind of stuff. So what should we look at now? We'll have a look at, so how do we handle the cursors now? So let me find it. Right, so to handle the cursors, first of all, I've got an enum. This hover over, see down here, it's in my enum. So the mouse cursor could be either hovering over the menu or land, friendly unit, friendly building, enemy building. Now, the thing that determines the cursor is what's currently selected and what you're currently hovering over. And these are all the different interaction states here that I can think of anyway that you're going to need. So either nothing, you'll have your normal cursor. Invalid, I think if you had a building selected and you were trying to move it somewhere, obviously that can't work. You've got move, attack, select, deploy, interact. So if you're taking a vehicle onto a repair building. And you've got sell, can't sell, fix and can't fix. So how this works. So we come in, we raycast. We're raycasting against everything except layer 16. Layer 16 is my camera plane. My camera plane is only used to determine the OpenGL view, this white viewport here. That's all I use the camera plane for. So there's no point in raycasting against that. I'm not fussed about it. Yeah, that little bit there just means invert, so that just means everything except layer 16. And then you see, so we get the current object, make a switch. All my units as well, I use layers to determine whether they're friendly and whether the unit are a building or not. And then there's also like the terrain's a different layer, the shroud's also a different layer, so that's why there's two cases bunched up there. And then so from that we can tell what we're hovering over. Now once we know what we're hovering over, we then need to know what we've got selected and if what we've got selected can interact with what we're hovering over. So that's what I do here. So if we're hovering over the menu and we have no selected objects, or active objects, that's objects that can receive an order, and we don't have any of the support selected, so that's sell or fix. Then we can just go straight into this calculate interaction method. And then you can see here we're setting up. Yeah, so the interaction state there will be nothing, unless we're hovering over a friendly building and we have one of these support cells or fixed selected. And you can see there that we're changing the interaction state. As well as if you're hovering over a friendly building, as well it'll go to the select state. Yeah, so that's if we have no unit selected. So you see there, if we have one unit selected, again we just need to figure out how that one unit that's selected can interact with whatever we're hovering over. And again, that's what we do. We've got another calculate interaction method here. And then we just go in that. We say, alright, if the object's attackable and we're hovering over an enemy unit, then attack interaction state, and you've got deploy, you've got interact. Move if you're hovering over terrain. So that's that bit. But if you have lots of units selected, then you need... What I do is it'll iterate through every single unit, and if it can find a unit that's meant to interact with whatever you're hovering over, then it'll just instantly take that interaction state. If not, then it'll default back. It'll probably be invalid if nothing can interact with it. But if something can, then it'll go through the list, it'll find it. So that's what handles. That's what chooses our interaction state. And then we have a cursor manager. Which actually handles drawing the cursor. You see there, as our own GUI method. As well as the cursor's animated, this looks after the animation. And that's also update cursor. That's where we tell it what cursor we want. You see there we're casting the interaction state. If I just go back to my UI manager, You can see here on the add to action state, my enums, I've not only have I set it there, but I've also given it a number, so I can cast it as an int. Let me find it. So that's why I can cast that as an int and get directly to the index for cursors to choose which one. All the cursors are in the cursors game object, so you can see here, so if they are animated, you've just got to show the animations. So that's how that works. Let's see if we run it, you can see it works. So it's got select, so that's deployable. In fact, if I pause it, and if I get rid of, I'm not sure if this is going to work. No, I can't show you that. But if it wasn't movable, then it'd come up with the red invalid option. You see there, we're moving about. Some other things as well. So yeah, we'll have a look at the minimap now and how that works. I'll find my minimap controller. Where will it be? So the minimap. Now, the minimap, I'm not using a render to texture, I'm using another viewport. And the reason for that is because I'm wanting to draw that OpenGL viewport on top of it. Now if you use a render texture, you can't, anything on the GUI will automatically cover up OpenGL drawn objects. So that's why I'm having to use the viewport. I mean, so here we're just doing some maths because we've got to figure it, because it always wants to be a square no matter what the resolution is. So you see here, if I change, at the moment we're in 3 aspect, but if I change it to 4:3, so you see it's still a square. You can see the screen's tiny, but it'll always be a square. So that's what all this bit is at the first. So we find out what height we want it to be, then we calculate the width based on the height, then we assign the viewport. Then once we have the minimap size as well, then we can start to build the GUI. See, it's a bit annoying, the GUI on this bit, because I said textures will cover it up. So these are all different blocks to the left, above, to the right and below it. So once we have the minimap dimensions though, we can then calculate that. So that's what all this is. The map bounds, we have to raycast again to find these white lines here. We've got raycast, so we're raycasting through that corner, that corner, that corner and that corner, and that's how we determine the points where to draw this. If you look, we should only be raycasting it to layer 16. Yeah, we are, so there's our camera plane. It helps out with efficiency a lot. So that's that a little bit. Right, and then when you click on the minimap, all we do is raycast through the minimap camera, find out where the point was where it raycasted, and then we've got a little bit of an offset though because we don't want the camera to be dead center. For example, so if I click on top of the tank, you see there the tank goes dead center. But if this menu wasn't here, it wouldn't be dead center. So that's why we've had to attach a little bit of an X offset. As well, where the camera is in relation to the tank, there's a bit of a Z offset as well. And they're calculated at runtime. Yeah, I think they're calculated by the main camera. So that's how we do the offsets. Update the viewport, so obviously when we're scrolling in and out or moving, we then need to figure out, we then need to draw the updated viewport. So you see there we're raycasting at layer 16. And then on post render, this is where we're using the OpenGL to actually draw it. Because I couldn't, as far as I'm aware, there's actually just no straight line function in for the GUI for diagonal lines and that, so that was why I ended up using OpenGL. So that's that bit. So quickly run through some other things. A lot of this is unfinished at the moment. I say I've had to quickly do some little bits to get it working. So you see here we've got this RTS object, building and unit. This is what everything's going to derive from. You see there our RTS object. Everything's going to have a set selected, set deselected method, assign to group, move from group, change teams. Everything will have a name and health as well. And then you see from that, unit derives from that. And so there's building and then so forth. So if we find tank script, wherever it might be, units here, vehicles, if we go tank, yeah, you see tank derives from vehicle. So that's how that works. Some other things as well, got some static classes here, so text generator. Like this black background, there's no point just creating a black texture and importing it to Unity. You might as well create it yourself. So that's why I've got this static texture class. So it'll just return me a single pixel texture of whatever colour I specify. So that's how I get my textures. That's the shader for the OpenGL. Again, static class, just so I can instantly access it. I've also got this model resolver and resolver config. Now, they're used to get hold of other scripts. Now, if you saw my original RTS, I first tried, all I did was try updating one script. But every single script was talking to each other. Everything was so tightly coupled that as soon as I changed one script, I had to go and change something else, and then something else. And it's such a bad way of programming like that. So that's why what you should do is program against an interface rather than directly against something else. So this is what my model resolver is. So when I say model resolve.resolve and I pass it a interface, so where can I show? I think this is quite a good example. So you can see here, I want to get hold of my events manager to attach all these methods to the events. So you see there I'm saying model resolver resolve events manager, and how it knows how to do that is everything's set up in this resolver config. So you see I'm registering the events manager there against events manager.main, so that's my singleton in events manager. In fact, I can show you that. Yeah, there's my singleton. So that's how the model resolver works, and that's how I also get access to other files. And the best thing about that though is that if I go and create another file now, all I have to do is make sure it satisfies the interface, and I know it will work. So that's why it's always good to program against an interface and never directly against a concrete class. Let's have a look at what else. Oh, we've got our main camera. So you can see here, this is where we set up our starting position. So we've got our start point, which is a public game object, I believe you have that. That's where we set up the rotation. And also this is where we pan and we move and we zoom as well. And we don't want to scroll off the edges as well. So if hang on a sec, I'll go back to free aspect. You see here, so if I go to the edge now, obviously when we get to it, we want it to stop when it gets to the edge there. Starts up making camera, taking care of all that. Check edge movement. Setting the boundaries. See what else we got. Yeah, that's just the start point. Oh yeah, these are my orders. So I say at the moment I've only really implemented the stop order, I believe. But that's how I'm going to tell units what to do. I'm going to be using these orders. Got some constants. Oh yeah, this is so if I want to change the teams, or if I want to know what team something's on, rather than say if this equals 1 or 2, from that I can just say now this equals const.team GRI. It just makes it a lot clearer. Remember, when you're programming, what you really want to think about is if someone who's never seen your code before came up to it, would they be able to navigate it and find what they wanted to find? And in my old project, there's just no way anyone could have done that. It was just such a mess. So it's a lot better to have it like this, because I remember when I first started seeing scripts like this as well, and there's loads of scripts which could have probably been done in a few scripts. I was thinking, why? What's the point? But it's just if you ever start working on a big game with a big team, you just have to do it like this. Otherwise, it just becomes unbearable to try and work through it. So a couple of things. So yeah, we've got some other core. Oh yeah. So there are core units. So it will either be air, infantry, or vehicle. If it's a unit. I don't think they're really implementing much. Oh yeah, we're using require components as well, so when you drag one on, it'll automatically add all the other components you need. As I read it, a script, that's for our minimap control. You see if we click on minimap camera, you see we've got a center camera here, and that's just so you can move the camera into the center. But then wherever you move the camera, this is what defines the boundaries of the game. So if I move the camera to there, you can see here everything's moved off to the right now. So it's the minimap camera that actually determines the boundaries. Now, so all you got to do is just set where you can hit that, set it up, and then just move it where you want. Yeah, you can also zoom in and out. So if I see here, if I make this a lot smaller, move it a little bit. That might be too small actually. Try that. Yeah, you can see here. I mean, it's messing up a bit because it thinks it's gone out of the boundaries. You can see here, so the size determines the size of the camera also determines the boundaries. Let's have a little look else what we got here. So we've got our custom event args here. That's my custom mouse event args. The GUI manager. The GUI's not really doing much at the moment. Let's say apart from drawing those backgrounds, and that's where that's all done. That's where it calculates the right screen pixel space to draw them around the minimap. Module drag select. If I'm showing this, so the drag select thing there. That's all done in that script. So yeah, there's all the interfaces for my managers. There's the interface of my unit actions as well. ItemDB, again this isn't fully populated, but this is what I'll be using to give every unit all the parameters, how much speed they've got, how much damage they can do, how much health, what their name is, the link to the model and everything like that. All that will occur in the ItemDB. Item's just a class that the ItemDB will store. See there we've got manager. Manager's not doing anything at the moment. That's just a waypoint gizmo. Got my movement classes. See there, my base movement is an abstract class, and then from that derive air movement, infantry movement, vehicle movement, because they're all going to be handled differently. At the moment I'm just using the navmesh agent, but I won't be later on. I'll be using my own pathfinding. I've just set it up with the navmesh agent for the moment just to demonstrate it. Selected unit, this is our selected manager. If we go in here, so this is when you give an order to something, it's our selected manager that will give the order to all the selected objects. You can see there, selected is the script that actually draws the the overlay kind of thing. You see here when I select it, that's what's selected drawing that. I think I'm going to change that though, because at the moment I've got it to change size depending on how large the unit appears on the screen. So you can see here as it rotates, it changes size. I'm not really too keen on that, so I'm probably going to change that pretty soon. Overlays, that's what actually generates the overlay that gets displayed for the GUI. And then you see we've just got some unit scripts. Also got some scripts for the menus. Now this is something else that I want to show you. So if I load up my main menu, now what I wanted, I haven't put any effort into this really, but what I was looking at was how to do loading screens between loading scenes. So you see if I click new game, get loading screen, and then the screen disappears once it's loaded. Now I had a look online about how other people were doing this, and there wasn't too much on it, and the stuff that was on it wasn't really too good, I didn't think. So I created my own little level loader here if you want to see how it's done. So you see whenever I load levels, I come directly into this class. I'll say load level, pass it a level ID, and then it'll set mloading to true and it will load the level. Now this object, this level loader, I should have it set to don't destroy on load. Yeah, don't destroy on load there. So whenever we're loading a different scene, we won't lose this object. And then you see, so as soon as we set loading to true, it'll start drawing it on the GUI. And then we've got this function here, on level was loaded. And then I only found out about this function a few days ago. Once I found out about this, I was thinking, well, this is brilliant. This is how you can make an easy loading screen between levels. So that's how that works. Yeah, and that's pretty much it for now. Yeah, so I say, yeah, just have a look through, have a little bit of play about. Yeah, but that's the introduction to a basic user interface for the RTS. Thanks for watching.